Thank you so much, Daniel. Although I won't have you impugning the Italian railway system, it was actually only a 30-minute train, so even better. As Daniel mentioned, I was here 2 years ago at Pragma, or not here, but in Verona. And it's such an honor to be back in front of this crowd. I love this country. We are spending a month here, which is great, in Florence. But I'm not here to talk to you about Florence. I'm here to talk to you about code. This is a class. This is a class I really like. It's a network client. And there's got some promises and generics. But if you're not comfortable with that stuff, don't worry too much. You don't need to understand it to understand the whole talk. The class is pretty straightforward. It does about 4 things. First, it creates a URL request. It sends the URL request. It checks the status code when it comes back to make sure that it's a valid status code. And lastly, it decodes some JSON. Oop. So this is a class. I really like it. I like it because it's short. I like it also because it's testable. We've heard a little bit about testing throughout this conference, but that's a really important part of the code that we write. But how do we actually know that a bit of code is testable? What gives us the knowledge that, like, hey, this is good code and it's testable, and this is not as easy to test code? How do we know? Well, we know a couple things about the code. We know that it has only one singleton, which makes mocking that singleton and testing pretty easy. So we have this URL session at the top. That's our one singleton. And if we want to test this class, we would kind of wrap it in a protocol, maybe use dependency injection, put it in the initializer, save it, and then we can use it. Now, this class doesn't know if it's talking to a real URL session or a mock URL session. So that's really good. That's one way that we know that this class is testable. It's pretty easily mockable, so that's good. Another way, if you attended Matt's talk last night, one of the audience members asked a question. His name was Gregory. He asked about cyclomatic complexity. Now, maybe everybody doesn't know what cyclomatic complexity is, so I'm here to tell you it's branches. It's how many branches you have in your code. And so we can kind of walk through our code and count how many branches it has. So we know that our first branch, or our first path that we go through the code, that's the happy path, right? So we sort of create our URL request. We send it. We check the status code. Status code is good. And we decode the JSON, and that works. So that's our happy path. The second path through this code is what if there's a network error, right? We construct our URL request. We send it. And then there's an error in there somewhere. So that's the second branch of code. Third branch is a status code error, right? So we could go into that little throw over there. So we have our URL request, we create it, we send it, we check the status code, but that actually fails and goes in here, throws an error. So that's our third branch. And then our last branch is what if there was a JSON decoding error? So we, again, create the URL request, send it, check the status code, go to decode it, but the data's garbage, can't be decoded. And so that's our last branch. So 4 branches roughly means 4 tests. If you write 4 tests for this class, you'll be able to run through all of the lines of code in the class, right? So 4 tests, that's pretty good. That's not too many. Yeah, so this is my class. I like my class. I wrote it. I'm very proud of it. But of course, something's going to happen, and everybody knows what's going to happen. And it's that somebody's going to come to you, and they're going to say, listen, I'm actually going to need you to go ahead and add a feature to our app. And you say, but I wrote this code. It's so nice. It's so clean. Why do I have to add the feature? And say, listen, we pay you to add features. We don't pay you to look at nice code. So we say, fine. OK, we want to add a feature. They say, listen, we need authentication. It's very important for us. So you're going to have to go ahead and add authentication tokens to the app. All right, fine. And maybe we work at Sasha's messaging startup. And they say, well, we also need background handling because the user's sending messages and they need to be able to send the messages offline. So we add background task handling. OK, fine. Another feature. And then somebody else comes along and says, well, we actually also need to support the little network activity indicator for iPhone 8 devices. I know this API is actually deprecated now, but we still have people on iOS 8 devices, and they need this support. So we add that. We add some counters to make sure that the requests are counted correctly and that the activity indicator is turned on and off. So our code that was once so beautiful turns out messy, right? And I wouldn't dare call it spaghetti code because I really, really love this country. Okay, but it did get messy, all right? And you know, what happened here? Like, what went wrong? We had to add a bunch of features, and we added them sort of willy-nilly. But we hit a point of complexity where we say, okay, we actually want to turn around, we want to simplify this. We want to take some steps and make this code simpler, easier to understand, easier to test, all those things. So why do we choose now instead of before now or after now? Well, one reason we choose now is there's some things that have happened to this code, right? Before, it mostly had one responsibility, which was to get stuff from the network and give you an object. But now it has many more responsibilities, so we've kind of broken this single responsibility principle. What are the responsibilities? We have this like auth token stuff, we have this like background task stuff, this request counter stuff. So that's like pretty frustrating. Got all these responsibilities in here, so that's like a sign that maybe it's time to refactor this or think about it. Also, we can go back to look at the cyclomatic complexity. I'm not going to count all the branches here, because it would take a while. But I will tell you roughly how many there are. There's 2 up here, there's 2 there, there's 3 here. There's the original 4 that we had, and then there's another 2 at the end here. And we have to combine all of these branches in some way. Does anybody know how we combine them to figure out our final total of number of branches? Any guesses? Yes, we multiply them. And when you multiply, you get 96, which means you have to write 96 tests to run through every line of code and every path in this class, which is, I've barely written 96 tests in my life, so this is not going to work for me. All right, so cyclomatic complexity, that's another problem. And the other one, which I think is handy and always useful, is how long is the code? The code is just longer now. It's longer, and we want to make it shorter and nicer. So we've got this code, and we've got a couple of things in our toolbox, right? What should we try here? We can try a couple of things. One thing we can try is we can try maybe deduplicating some code. That could work. So let's look at our class. And you don't need to read this, just kind of look at the shape of it, and you see there's like these 2 chunks that are exactly the same. So that's cool. Well, why don't we extract that and call that function? That's a little bit better, I guess. I don't really know if that's better, actually. So deduplication is not really helping us here because we don't have any code that is identical, right? We have a little bit, but it doesn't do much. Well, what else can we do? We can maybe extract some functions, right? Give them some names, and maybe that will help us understand this code. So for example, we have this. We have these incrementing and decrementing on the request counter. And so, yeah, so maybe we wrap those up in a function, give them a nice name. Okay, we call it increment and decrement. And actually, if you look at it, these are kind of 2 similar-esque functions. So what if we made a new function called adjust by value, and then we could call that with the 1 and the -1. And, well, that's actually a magic number, so let's go ahead and put this in a constants file. Okay, and I think a K networking adjustment increment is a really nice name. And like this is, is this abstraction? Is this really, what are we doing here? So I would call this extraction, and I think that there's times when it can be useful, but here, you know, as we process this code, we aren't really getting anything out of extraction because we're really just moving things around. We're not adding new things to the code that help the understanding of the people who are coming to read the code. So if you write this code, someone will come along, one of your coworkers will try to read it, and then they'll subtweet you, and they'll say, I want to beat OOP programmers over the head with a giant sign that says indirection is not abstraction. Digging through unpleasant source code to fix a bug. Repeat after me. Indirection is not abstraction. Please don't confuse indirection with abstraction. Overheard, we love indirection. It's kind of like abstraction, only easier, right? And this is my personal favorite. Before using the word abstraction or even forming an opinion about it, explain the difference between it and indirection to someone. So that's kind of what I want to do here. I want to talk about what abstraction is, and I want to talk about what it means, how it's different than indirection, and why we choose to do it over these other techniques. Right? So what we're here to learn is how to abstract things. I have a sort of 5-step process that I'm going to walk everybody through that shows you sort of how I think about this stuff. And the first step is you need to find some axis of similarity in your problem, right? And so this is something where we need to find some things that are similar so that we can kind of draw some lines, cut some code, and separate it out into different components. So one way to look at this is we can look at those responsibilities we talked about earlier. And we can say, well, we have our 3 responsibilities. That's nice. What if we could kind of pull those out into a class, move them to the top, and then kind of stuff the code inside each of those little objects, right? And we zoom in on that and take a look. And this is not bad, actually. This is pretty good. And if we kind of take a closer look, we see there's sort of a shape here, right? There's this bit, which just adds headers, right? There's this bit, which happens right before you send the request. And there's this bit, which happens right after you send the request. right? And if you stare at this kind of long enough, you can sort of maybe decide to rename these to like add headers. There's some before code, some after code. And you end up with this kind of vague structure. And you say, wow, why don't I I've got some shared methods here, some shared concepts. Maybe I can turn this into a protocol, right? So you turn it into a protocol, call it request behavior maybe. And this is pretty good. Honestly, I did this for like a year or a year and a half. But there's some problems with it. And it doesn't necessarily solve every issue that we have. So for example, like what's going on with this, right? This code isn't really fitting into any of our request behaviors. It's just kind of there. And it's important, we do need it, but why is it so special, right? Why is this error handling set apart from the rest? Why is it not extracted? Well, I don't really have a good answer for that. And these two, why are these different, right? They both just happen before the request. I don't really care when they happen. They just need to happen before the request. They could be the same. So these two things kind of seem similar. Why are we treating them differently? And so I have this quote that I really like. I learned it very recently. It's from Shigeru Miyamoto, who is a designer at Nintendo. He's made tons of games that everyone loves. And he says, a good idea is something that does not solve just one single problem, but can rather solve multiple problems at once. And so it took me a little while, but I actually had an epiphany, and I could not have had it without Rob Napier, who's a great speaker. I was watching his talk. It's called Generics It's Not Supposed to Hurt. And he's also turned into a blog post series. I asked him, how should I point the audience? He said, start with this blog post. So this is a great blog post. It's, I think, 8 or 10 blog posts. It's a good amount of stuff, but it's a really smart approach to this problem, and it actually turned everything I think about this problem on its head. And so I want to thank Rob for coming up with this concept. But to sort of take a look at what we want to do, right, we have all these different components, right? We have our auth token, our background error counter. Those are sort of our side behaviors. Right? But we also have these core things, like checking the status code or actually executing the request. And what if we could treat them all the same? What if all of them could just be one thing? Right? And to kind of see how that might work, let's ignore everything except for our special methods here. Right? And if we go ahead and swap the order of the bottom two, and then maybe re-indent it, and then kind of squish it up a little bit, we start to see a kind of interesting structure here. Right? These things kind of nest inside one another. And we can actually even add our status code handling in there. So we built this kind of like nested structure where everybody has a chance to do something on the way out and a chance to do something on the way in. And so we can sort of take this and sort of replace each component and say, okay, well, our URL session is our core. That's the thing that actually sends the request. And when that happens, we want to validate status codes. And when that happens, we want to count the requests. And when that happens, we want to check our leases on our background identifiers, and we want to authenticate on top of all of that. And so we've kind of built this sort of little mini tree for ourselves of all the behaviors. And if you attended Daniel's workshop about SwiftUI, this starts to look kind of familiar, because this is how SwiftUI works too, right? SwiftUI, every property that you add to a new view ends up being a wrapper around some central view. So if you want to have a text and you want to add a text color to it, you wrap it in a new view that adds a text color. And if you want to add a background color, you wrap that. If you want to add a padding, you wrap that. But when you're writing SwiftUI code, you don't write it like this in this nested style. You actually use these modifiers, and we can just steal that. So we can kind of wrap up our little behaviors and put them in these little modifiers, and we end up with a very descriptive way to talk about how we want to send network requests. Right? We say, well, every time we send something through the URL session, we want it to check status codes. We want it to count the number of requests and set up the little spinner. We want to handle background tasks, and we want to make sure that we authenticate as well. So this is actually pretty nice, and this structure could potentially work for us. So that's step number one, is find out where the similarities lie, where the structure is in the problem, and see if you can break something down. Once you've done that, it's time to actually develop the abstraction and see if what you've sort of theorized will actually work in practice, right? So our core protocol is this. Rob calls it a transport, and I've actually stolen that. And so we call it a transport, and it has one method. You just can send a URL request, and you get back data and an HTTP URL response in sort of a promise async wrapper. Great. Conforming URL session to that is very, very easy, so that's fine. We can sort of do that. And then we want to add this status code checking behavior because that doesn't exist in the URL session. So we want to build this, right? And we want to create a new transport, and we want to conform to this protocol. But the status code checking transport needs something to check, right? So it needs to wrap another transport. So this is kind of its core element. And this just sets up the initialize and everything. You're going to see this a lot, so get used to this. This boilerplate you're going to see a lot. And it's a transport, so it needs a send method, and you set up the send method. And in here, really all you have to do is forward to the child transport, right? And the nice thing here is that anything that happens before you do the forwarding happens before the send happened, and anything happens inside that completion block happens after the request comes back, right? And so that gives us a chance to do things before and after any given request. So we'll move that a little bit, and we can check our status codes, make sure it's 200 to 299, and then if it is not in that range, then we will throw a status code error, and we're in good shape. So now we've gone ahead and composed in a bit of extra behavior to something that was sort of provided to us by the system. That's pretty cool. But this is not the syntax that we want. This is the syntax that we want. So how do we write that? Very similar to some of the stuff we saw Paul write on stage. I don't know if he was writing or a ghost was writing or how that worked. But you can extend your transport just like you would extend a view in SwiftUI. And you can add a function called checking status codes that returns a new transport. And you would just put your code in there. Same code, same wrapping, and then you get the exact syntax that you want. So now we have a URL session that checks status codes for us, and we have cute syntax as well. So that's pretty good. Another one that would be really useful to see how this works with is, let's say you want to add headers, right? So we work with JSON APIs a lot. When you work with the JSON API, you need to send an accept header and a content type header. So we need to be able to add headers. So how do we do that? This bit stays almost exactly the same. You just need to give it the actual headers that you want to send in addition to the transport that you're wrapping. And we have our send method, again, very similar. But here we're going to do some work before the request comes back. And so the work that we want to do, well, we need to modify the URL request. URL request is a struct, so we need to make a variable version so that it can be mutable. So we make this mutable copy. We loop through all our headers, add all the headers to the mutable URL request, and then we send it, taking special care to send the mutated one and not the original one. And yeah, so that's how you would add headers in this world. And so you can write this the sort of longhand way where you create a header adding transport, you pass in what you want to wrap, you pass in the headers, or you can wrap it up in another SwiftUI modifier function. And so this gives us all the headers that we need for handling JSON with a cute little modifier right there. So you just say, URL session.shared, checking status codes, and adding JSON headers. It reads kind of cleanly. So that's pretty good. We've kind of worked with the abstraction a little bit. We think that maybe this can work out for us, right? So what's the next step? Actually, we're not on the next step yet. We're going to take a brief digression. We're going to go back and talk about deduplicating code. We talked about that as a potential strategy, and we showed that it doesn't really help us in this situation, right? Don't repeat yourself is something that you learn very early in your career, and it can be very helpful, but it definitely has its limitations, right? Don't repeat yourself can never get you to the structure that we found here, right? Because the code simply wasn't repeated. So if you think about it as a grid where either the code is repeated or it's not, that's the top part, and the concepts under the hood are either the same or they're not. You create these 4 boxes, right? And one of the boxes is just the code's not the same and the concepts aren't the same. That's fine. We don't really care about that. That's like, you have some image filter code over here and some audio player code over here. They have nothing to do with each other. That's fine. If the code looks the same and the concepts are the same, then you're in good shape because that is just, it looks like code and you can apply the don't repeat yourself rule and you're fine. If you work on a team, maybe somebody's already done this for you. It's already probably taken care of. If your code looks the same, but your concepts under the hood are not the same, that's when you're in trouble. This is fortunately not the situation that we're in, but this is if you run into the situation where you have a function that you extracted because you need it in 2 places, and then you add a Boolean parameter, and then you add an optional parameter, and then you add another Boolean, and at the end of the day, you're like, what is going on in this function? It's huge, it's got all these paths in it, and all I want to do is like deduplicate these 3 lines of code, and I ended up with this messy function. That's what this is. But where we are is a little bit different because the code did not look the same, but we were able to find some structure underneath, and this is something that's potentially not abstracted in your code already, and somewhere where you can add a ton of value. So that's where we are, and that's where we're going to be. So this red box here, we're not going to talk about it too much today, but Sandy Metz has a great talk about it. And she says in it that duplication is far cheaper than the wrong abstraction. So that red box, that's the wrong abstraction. So hopefully we aren't there. Cool. So that sort of rounds out step 2. And we're on step 3, which is before we actually implement this everywhere, I want to take a look at what else can we build here, right? What else would be useful to have as we work in this new system? So one thing to be really useful is, I need to test stuff, right? So I need a way to mock a transport and just say, here's some fake data, just return to me this fake data whenever somebody calls you. So this has a data and an HTTP URL response, and it just returns that anytime somebody calls it. Boring initializer, who cares? And this is a somewhat more interesting initializer. What if you just give me a status code, and I'll give you a fully baked mock transport? And so there's some boilerplate in here to set up the HTTP URL response, some very scary exclamation points. But at the end of the day, this does what we want it to do. And it enables us to build these little helper functions like mock transport.ok, which always returns 200, or mock transport.serverError, which always returns 500. And you could build JSON helpers in here. It's like, oh, return to me this codable object whenever I call you. And you can build a lot more stuff here, but this is the basic core of the idea. And so when you go to test your view controller, you now no longer pass in a URL session, you pass in a transport. And this transport can be anything. So it can be this mock that you've set up for yourself. So that's pretty useful. Another thing that might be useful for testing some of our other transports is I would like to be able to inspect every request that you see. So let's say I added some headers. I want to make sure I really did add those headers correctly. So I might want to be able to inspect requests that come through here. So I need a property to save that request that we saw, right? We need another boring boilerplate initializer to set up the wrapped transport. And inside our send method, when we see a request, we save the request. Simple as that. And then we just pass on to our wrapped thing and move on. And now you can examine this after your test is fully set up and check to make sure that the URL request that this saw is the same as the URL request that you sent. So you can test stuff that way. So that's really handy too. Another really handy thing that you might want, here we send a request and we get back a data and a response. I don't really want that. I don't need data. I don't know what to do with that. I want my model object, right? And so combine gives us a handy tool. It's a little function called decode, which will, there we go, which will decode a specific user or a specific decodable type, in this case user, and it will give you that type, and then you're happy, which is great. So we want this functionality. How do we get this? This is going to be a little bit of messy generics, so if you're not super comfortable with generics, just shield your eyes. We're going to extend the promise type, right? And we only want to extend it in the context that we're in. So only when there's a data and a URL response in the sort of body of the promise. We know we want to put a function in there. We know it wants to be called decode. It's going to need to take some type, and it's going to return a promise of that type. But we need a way to talk about that type. We need a name for that type, right? So that's where the generics come in. And so we say it's going to be called the type to decode, really friendly name. And we know we can pass in the type to decode in the parameter, and we can return it in the promise as well. And the last little bit that we need is we need to say, hey, type to decode really has to be decodable. Oops. Has to be decodable. If it's not decodable, this whole thing's not going to work. So we tell it, you got to be decodable. That's the bulk of the crazy generics. We sort of wait until the data and response comes back, and then we call into the JSON decoder, decode the type that we want, and return it back to us. And then we get this fancy syntax, which is great, and stolen from Combine. They say Gradar steal. I don't know if that's true. Cool. So those are some of the sort of tools that can help us in this process. So we want to build some of those to make sure that as we build everything else, our road is kind of smooth for us. After we've built the various tools that we need, it's time to actually do the work of extracting the things that we talked about. So one of those responsibilities was the authentication. We want to be able to put that into a transport. So we have an authenticating transport. Very similar, again, put this boilerplate there because you always need that wrapped value. And then when you go to send, again, we make a mutable copy of the request so that we can change it. We grab our auth token out of user defaults, probably a little safer if you do it out of the keychain. This is just demo code. And then we mutate the request, and we add our header. So that's good. And then we can just call wrap.send with our new value, and we're in good shape. So this is all the code that we need for the authenticating transport. A lot simpler, a lot shorter, easier to test. We get all those benefits that we want back. We can build another SwiftUI-esque modifier for it, and we can add that onto our little stack. So we were slowly building up this stack to contain all the different behaviors that we want. So that's step 4, extract. You could do the same thing with the background task identifiers, with the request counters, all that stuff. I won't walk you through that. Don't want to bore anybody. And then step 5 is you reap the benefits, right? What did we gain here? Well, we gained the ability to build new things that we weren't able to build before. Before, if someone came to you and said, hey, I think some of our requests are taking a long time, but I don't really know which ones, and can you figure out what's going on with that? And you say, well, now I got to add this timing code into this messy bit of this messy class, and I don't really want to do that, so I'll add it, but then I'll delete it. But in this world, you can just add more behaviors and keep them in their own place. So what if we built a timing transport, for example, right? Same boilerplate, keep track of that wrapped transport, and when you send the URL request, and forward it onto its child, before you do that, you want to grab a hold of the current date. Then, when the request comes back, whether it's a success or a failure, you always want to figure out the delta between when you sent it and now, and then you can print it, log it, put it in a database, do whatever you want. And the nice thing is you can fold this in to your stack, and then when you're done with that bit of testing, you just remove it from the stack, but leave this code. This code is still good. You might want this in the future. But you could just take it out of operation, which is really nice. So you can, so once you've built this structure for yourself, you can start to build other tools that you wouldn't have even considered building before. Now they're so obvious and so easy to build. So why did we do this? Why did we go through this whole abstraction process? What is it for? The main thing I think we get out of it is we get decoupling. Decoupling means that we get to treat things that are different as though they're separate items, right? When we treat them separately, we need a boundary between every single item. And for us, that boundary is this protocol. This protocol says, you don't know what's inside here. You just know that it's going to be something that conforms to this contract. And when you call it, it's just going to do something, and that's not your business anymore. And so when we have those boundaries in place, then our separate components get handled separately. Now, handle is a bit of a weasel word. What does handle mean? Well, I mean, I can be specific. I mean, you can test it. That's one, right? So we looked at this authenticating transport. There's a bit of boilerplate, but the main part is right here. There's 2 branches. Either the auth token exists or the auth token doesn't exist, right? And so that's 2 tests. You write 2 tests, and all this is fully tested, and it's pulled out of your main body of stuff, which is great. In addition to being able to test it, you can also reuse it. Right? So let's say you have 2 different parts of your app. User needs to be able to sign in. They can't be authenticated because they haven't authenticated yet. And so they might have a separate stack of network tools to be able to log in without authentication. And then once they're authenticated, they use a totally different one, which requires authentication. And you can now bake this into the code and say, hey, we know this request requires authentication because it's going through the authentication transport, which is pretty great. So you get the ability to reuse these little components and mix and match them as you need. Maybe it's HTTP, maybe it's some other protocol, maybe it is a different web service that needs different headers or needs to add a different style of auth token. You can compose all these things together and get somewhere really cool. And the last benefit is a little bit more hazy, but I still think it's important, is you can just look at the code and know that it works right. So this is a logging transfer, for example. You haven't seen this yet, but it's not a lot of code. You can kind of look at it and say, well, it prints something before it sends, and it prints something after it comes back. There's the important bit right there. And it looks pretty straightforward. Like I don't need to read this line by line to understand what it does. It fits into a structure that I understand, and it does a thing that it needs to do very simply. So yeah. I want to close on a quote by Pablo Picasso. He says that there is no abstract art, right? And we all know code is art. You must always start with something. Afterward, you can remove all traces of reality. And that's really what we've done here. We waited until the code got messy, right? Until things got out of hand, right? And we had something to then abstract away and find the structures underneath. And we removed the traces of reality because now the authentication transport doesn't know what it's doing. It just knows that it's adding some headers to a request and telling somebody else to send it. So it has no concept of reality, it has no concept of networking. It just knows, I'm going to do this thing, and then somebody else will handle it from there. So thank you all for your attention, and yeah, have a good rest of the conference. Have a good lunch, honestly.